Afternoon. Is it audible? My sound is clear. Okay, this is Unit 6 from Jan 2021 paper. So the first question, a ball rolls along a U-shaped track, as you can see. The ball oscillates in a vertical plane, like vertical oscillation is there, going up, then coming down, going up, then coming down. Describe how the time period of oscillation should be measured to make a reading as accurate as possible. So to determine the time period, what are the steps? First, we should always mark the mean and extreme position, because using a mean and extreme position, we can identify the oscillations easily. So we will mark the mean and extreme position, then we will record the time for, like example, 20 vibration or 10 vibration, and then divide by time recorded with number of vibration to calculate the time period. Is it clear, the first part? For any part, if you want me to write or like explained again, then I will repeat that part. But some questions are straightforward questions, that's why I did not write any type. Describe how a single measurement should be made accurately, how the measurement of a D should, how a single measure of D should be made. So what is D? D, they represent that. What is D here? You can see that it's a distance between the two tracks, like two sides of a track. So whenever we want to measure a distance, we should, and this is a horizontal distance. So what we should do, we should place a meter rule horizontally. And how we can make sure that the meter rule is exactly horizontal? By measuring the height of a meter rule from both ends. Like height of the meter rule from first and the second should be same. So when height of the meter rule is same from both ends, it means the meter rule is exactly horizontal. So we place a meter rule to make sure it is exactly horizontal. We'll measure the distance from both ends and avoid a parallax error, and we'll measure the distance between the two ends. Then a student determine the time period of different values. Yeah, spirit level, normally spirit level is used for uh, surfaces. Like example, when we have a surface, a floor, when we have a, if you use a spirit level here to make sure that meter rule is exactly horizontal. So when you place the spirit level over the meter rule will become like might become tilted because of the weight of the spirit level. So normally for the surfaces, when the whole surface is horizontal, for that we use a spirit level. Otherwise, we can use this technique which does not alter the position of a meter rule. The student determines the time period of a different values and D. She predicts that according to these oscillation, T is proportional to under root D. Show that her results are consistent. So this D is there. What we will do, we will take a value of under root D, like under root of this value 0.235, under root of this value 0.335, and under root of this value 0.445. So we'll take a root of these values, and whenever two values or two quantities are directly proportional, the ratio is constant. Like here, if T is proportional to under root D, the ratio between T and D should be constant. So how we can show? We'll take a root for D, all the values of a D, and then we will take a ratio between T over under root D. If we are getting a same answer for all the values, then we'll say they are directly proportional as the ratio is constant. Is it clear how we will make sure that T divided by under root D is constant? And if there was inversely proportional, then the product should be constant. Then question 2, two identical capacitors are connected in series and charged. They are discharged through a resistor and an ammeter. Student investigate how the current in resistors varied with the capacitor discharge. Appropriate circuit diagram, and we have to draw a circuit for, so two capacitors are connected in series. So two capacitors in series. First we charge the capacitor and then discharge. And remember, charging and discharging paths are always different. So we should, whenever charging and discharging, we want to observe for the same circuit. So we should use a two-way switch. Because in a two-way switch, we can change the position of a switch and observe the charging and discharging. So first, when switch is at this position, the capacitor will start to charge. And when we change the position of a switch, the capacitor will discharge. Like battery is disconnected or circuit is disconnected from the battery. One safety precaution a student should take whenever safety precaution is there related to this, because when we are using these capacitors, maybe chances there that maybe a high voltage is developed, so it may leads to an electric shock or electric current. So ensure that the potential or the voltage is not too high across the capacitor. Otherwise, if the voltage is too high, then it will produce a very large current that may electrocute or give an electric shock. When student has a stopwatch, describe how student should determine an accurate value of a total capacitance of capacitor. Look, the formula for capacitance, you have the formula Q is equals to CV. So total capacitance C is equals to Q divided by V. What is Q? Q is the charge. How we can find the charge? Because current is charge divided by time. So charge is current multiplied by time will be charge. So to determine the total capacitance, we need a current. So we will have an ammeter. We need a stopwatch. So we'll have, we need a time. So we need stopwatch. And to measure the voltage, we'll use a voltmeter. So how we carry out this? The total capacitance. So first, what we will do, like we will record the first part, we to know how much capacitance is there, and we can determine the current. How we can determine the current? We have an ammeter, so we can determine the current directly. And voltmeter is not given because in the question, as they already mentioned, student did not connect any voltmeter. So how to get the voltage? We have the formula V is equals to IR. So I is the current, we'll get by the ammeter, and R is the resistance. So how we'll get the resistance? The resistance what we are using for circuit. So we'll example select a proper or a specific value of a resistance. So we select a specific value of the resistance. Then after resistance, what we'll do, we will charge the capacitor fully. Then we'll like change the position of a two-way switch, and we'll start the timer or a stopwatch as we discharge the capacitor. And then what we will do, we will measure the current. Maximum current will be there by ammeter. and repeat the experiment. So as you can see clearly, to get the capacitance, it is Q divided by V, and Q is I into T divided by V. And V, so first we determine V by using IR. So we'll get the V. I is the current we already measured, and T is the time for a capacitor to charge or to discharge. So using this, we can work out the capacitance, the total capacitance. Or there's also another way, like we can also plot a graph between the current on y-axis and time on x-axis. The discharging is always exponential, in the beginning maximum, and it will discharge. So we'll use the formula that I is equals to I naught. I naught is the maximum current, e raised to power minus t over RC. So we'll have the maximum current I naught. We can have any current as I. We'll have T as well, as any specific time T, and R into C. So we can use this formula to work out the capacitance as well. Is it clear, this one, how to work out the capacitance? Then a student repeated the investigation, but a data logger instead of a stopwatch and ammeter. Why data logger would improve the invest? Basically, what is the advantage of the data logger? Data logger can take many readings in a short time. So at this, because like example, it is difficult to as a human being, it is difficult to read 2 meters simultaneously. But in a data logger, it by itself it will measure the time and current, and it will plot graph also, like it is connected to a computer. So automatically the graph will also be plotted, and we'll have more values or more reading in a short time. So the one advantage is it will take reading simultaneously for the current and time, and the second is we'll have many readings or many values in a short time. When high energy electron is incident on a sample of isotope, diffraction pattern produced. The diffraction pattern can be used to determine the radius of a nucleus of the isotope. The relation between the nucleus and the nucleon number is shown, where R naught is the radius of proton and neutron is constant. Explain why the graph of log R and log A could be used to determine the value of n. So how, if I take log both sides, so it will be log R is equals to log R naught into AN. Remember, whenever two quantities are in logarithm, while as they are multiplied, so we can write them in addition in log. So we can say this will be equal to log A plus log B. This is a function of like characteristic of a log. When two quantities are multiplied and log is written with them, so we can write log A plus log B. So here we can write log R is equals to log R naught plus log A. If we rearrange A into N, when we further simplify, this is log R naught plus log AN. And remember, whenever with a log, if it is written A raised to power B, so this B, the power will come as a coefficient, so it will be equal to B log A. So we can say log R equal log R naught plus N, because that's the power, log A. Now, if we rearrange the equation, so I can say log R equal to N log A plus log R naught. When I compare with the equation of a straight line, this is y equal mx plus c. So this is y, this one is x. So what will be the gradient? The gradient will be equal to n. So if we plot a graph, and y-intercept will be L log R naught, and the gradient of this graph will be equal to n. So we can use this to determine the value of n. So basically n is representing the gradient of a graph between log R and log A. Next, the table shows the value of R for some different isotopes. Plot graph for log R and log A and use additional column in the table your project. So basically here, and one more thing, student, what common mistake they do, always check for the units. Like here it is written femtometer. Femto means 10 power minus 15. So when students substitute, like example, write value of log A and log R, or log R and log A. So when student use this, they use this number only. Like you will write log 1.54 and what answer you will get, you will write. But that will be wrong. Why? Because it is femtometer. Femto means basically it is 1.54 into 10 to the power minus 15. So you will take log of 1.54 into 10 to the power minus 15. And you will plot the result. Is it clear how you complete the table? And after completing a table, you have to plot a graph. And after plotting a graph, you have to find the value of n. And we already worked out that the value of n is equals to the gradient of this graph. So we find the gradient, we'll get the value of n. Then determine the value of R naught, hence state the mathematical relation between R and A. Look, how to determine the value of R naught? If you remember the beginning, I got the equation log R is equals to n log A plus log R naught. So when we compare with the equation of straight line, this is y. This one is mx plus c. So on y-axis we have log r. On x-axis we have log a. So what will be the gradient? The gradient will be equal to n. And what about c? C is the y-intercept. So basically, when you plot the graph, what kind of graph you will have? You will have a straight line graph, but that is not passing through origin. It will have a y-intercept. So you will determine the y-intercept. You will find that y-intercept, and that y-intercept will be equal to log r naught. Like any value which is here, that will be equal to this. Is it clear? Then relation between the two quantities, if their ratio is constant, like example, ratio of A and R is constant, they will be directly proportional. If the ratio is not constant, so they are not directly proportional, but if one is increasing, other is also increasing. So you can say they will have a linear relation. Because three ways we can explain, like if one is increasing, other is also increasing, but and the ratio constant is directly. If one increase, other decrease, and the product constant inversely. And if one is increasing, other decrease, or but the ratio is not constant, it means we call that as a linear relation. So that finding a relation can only be done by plotting a graph and analyzing the final result. In question 4, a cylindrical container is made from a transparent material. Two students want to determine the density. A student need to measure the student need the measurement to determine the volume of a transparent material. The external diameter is approximately 10 centimeter. Student A suggests that measuring external diameter with a meter rule, and student B suggests placing a piece of string around the circumference and then measure the length of a string with a meter rule. Explain which of these measurements would have the least percentage uncertainty. So two ways are there. One is determining the diameter by using a meter rule. Another one is measuring a length, like turning string around a cylinder. Say this is a cylinder. We wrap the string around and say we determine the like 5 times this is wrapped. So the length, the total 5 divided by the total length divided by 5, so we will get the length for each or one. And then after getting a length for one, so we can determine the percentage uncertainty. So the idea is that which is having, when we compare the uncertainties, what is the uncertainty? Uncertainty means the smallest value which instrument can record. Because we are using the same instrument, so uncertainty will be same. The uncertainty will be same. But what about percentage uncertainty? The percentage uncertainty is uncertainty divided by value recorded into 100. So if you directly determine the diameter, if you directly determine this diameter, you will get the length, the value will be recorded. So uncertainty divided by length recorded into 100. But here we will have a shorter length because we are only determining one value. Here what happened, like more turns are there, greater value recorded. So if more value recorded, the percentage uncertainty will be less or lower. So student 2 will have a lower percentage uncertainty than student A. Is it clear? Then a student decided to use a string to determine the circumference of a container. They measure the thickness of a string using a micrometer. Explain two technique that could use to make ensure that the measurement. So how we can use a micrometer to measure the thickness? So we should always check for zero error, and we should repeat the experiment with different orientation, because maybe some side the thickness is not same the other side. So, and this is a string, so we should not tightly close the micrometer, otherwise it will deform the string. When the following measurements were obtained, the mean value for t millimeter and its uncertainty. So what is the mean value, the average value? So we have 2.15, 2.06, 2.13, 2.08, and 2.10. So what we do, we add them, the 5 value 2.15, 2.06, 2.13, 2.08, 2.10 divide by 5. So the average, the mean will be 2.10 millimeter. Then it's uncertainty. How to determine the uncertainty of a group data? The formula is maximum minus minimum divided by 2. That's a uncertainty of a group data. And we have to, if any anomalous result is there, so we neglect that. But here all appear to be in the same order. So the maximum value for this is 2.15 and the minimum is 2.06 into 100. So 2.15 minus 2.06 divided by 2, this will give us the uncertainty of the apparatus, which is 0.045. Because 2.15 minus 2.06, or we can say 0.15 minus 0.06, that is 0.45. Sorry, not 0.045, this is 0.45. Yeah, 0.045 and 0.045 divided by 2, which is 0.02. Because maximum minus minimum divided by 2. So 0.022. Is it clear? This is a half range. When we divide by 2, we get the half range. Maximum minus minimum divided by 2 is giving us a half range. If only maximum minus minimum, that's a full range. Then 4C1, the circumference of a container can be determined by using a formula where x is the length of a string. Calculate the value of c in centimeter. So we have t in millimeter. Here this t is in millimeter. So first we have to convert, and x is also already in centimeter. So we'll get the value. We just have to substitute. Like here t, the average, the mean was there, which was 2.10. So 2.10 millimeter or 0.21 centimeter. Calculate the value of c in centimeter, which is 25.8 minus pi, which is 3.14, multiplied by t, which is 0.21. So this will give us 25.1 centimeter. And the next part, we need the uncertainty in C. Show that the uncertainty is of approximately 0.1. So how we can determine the, 0.2. So how to determine the uncertainty is 0.2? Look, uncertainty even added, like it is, uncertainty is always added. So we need the approximate uncertainty in C, the value of the C. So we already have the uncertainty. We already have the uncertainty in the value of, because when you work out, see, this x was having uncertainty 0.2, and t is also having uncertainty 0.022. So this was 0.2, and uncertainty always add. Pi is 3.14. So this is 0.022. This will be 0.22, which is approximately equal to 0.2 centimeter. So uncertainty is when the units are same, with all, even the quantities we are getting by subtraction, but uncertainty always add up. Then the volume is there, which is given by a formula. Determine the value of V and uncertainty. Value of the V you just only substitute, but how to determine the uncertainty part? Because for getting a V, you just have to substitute the value. Now to get the uncertainties, look, when units are not same, we use the percentage uncertainty rather than uncertainty. So we find the total percentage uncertainty. So what we can do, uncertainty in C. What was the uncertainty in C? 0.2, and the value of the C is also there. So because they have different units, so what we'll do, we'll find the percentage uncertainty in each and we'll add them. So percentage uncertainty in C is the uncertainty divided by value recorded. What was the value recorded for C? The value recorded was, when you get the answer, so it will be 25.1 into 100. And what answer we will get, we'll multiply that by 2 because it is C square. So 0.2 divided by 25.1 into 100, this will give us 0.79, and this 0.79. But what is the uncertainty in C square? So it will be multiplied by 2, which is equal to 1.6, 1.59 or 1.6%. So C square is having an uncertainty of 1.6. Same way we'll determine the uncertainty in L. The percentage uncertainty in L, 0.05 divided by 19.9. So 0.05 divided by 19.9 into 100, that's equal to 0.25. So 0.25% uncertainty is there, and VI is equals to 5 divided by 810 into 100. So 810 into 100. This is 0.61%. So what is the total uncertainty? 1.6 plus 0.25 plus 1. So 1.6 plus 0.25 plus 0.61. So the total uncertainty will be 2.46% uncertainty. But this is a percentage uncertainty. Then we will determine the uncertainty. How to determine the uncertainty? The number, like what is the value of V? So after getting the value of a V, we will take 2.46% of V to get the uncertainty in value of V. Is it clear? The table shows some common material used to manufacture only borosilicate is safe to heat directly in a Bunsen burner. The density, the mass is given, deduce whether the container is safe to heat directly with a Bunsen burner. So what we will do, we will find, because we have the density of different materials are there, mass of a material is given and volume we determine. So mass divided by volume will get the density. So density is mass over volume. And after getting a density, the uncertainty will determine the uncertainty in the density. So 4 marks. So our first part will be density is mass over volume. So volume is already given and the mass is there. So mass divided by volume will get its density. And using the density and the uncertainty in volume and uncertainty in mass, will find the total uncertainty in the density. So this will be 463. An example, the volume is 188. So the density is 2.46 gram per centimeter cube. Then we'll determine the uncertainty in density. The percentage uncertainty is already there in volume. Then we'll determine the percentage uncertainty in mass, which is 1 divided by, as I mentioned here, this is 1 divided by 463. This will give into 100. This will give us a percentage uncertainty in the mass, which is 0.21%. So 0.21% uncertainty in mass, and the volume uncertainty is already there, which we calculated. That was around 2.4, I guess. So using the uncertainty in the volume and the mass, and we'll add them to get the percentage uncertainty, and we'll find, like, after getting a percentage uncertainty example, any number will come out. So we'll find how much increase is there, the uncertainty increase and uncertainty decrease. So we'll check the upper and the lower limit, upper values and the lower values, and using, if the density what we calculated, because what it shows like which material we want to determine the material, so we want to compare the density. So 2.4, what answer we'll get in 2.46, we'll check the upper and the lower limit of 2.46, and then we'll compare in which one it matches with. So that will be the material from which this container is made from. Is it clear? Or you can calculate the percentage uncertainty. How do we do this upper and lower limit? After getting a percentage uncertainty, because I did not calculate the volume, that's why I cannot have the percentage uncertainty part. What you will do after getting a density, this whole part is their volume cm cube. So I'll use a marking scheme answer. The last answer, this was part D. Yeah, so the last answer, this volume the volume is 24. No, volume is 188. Okay. And the uncertainty is 23. So this volume is 188 and the uncertainty is 23. Now what we have to do, we have to find the first density. So we determine the density. Density is mass present in a unit volume. The mass is 463 and the volume that we calculated 188. So mass divided by volume, we will get the density of this sample. And then using a percentage uncertainty, you will determine how much increase or decrease is there. Like what could be the possible maximum answer and minimum answer. So 2.46 gram per centimeter cube. Then what about the percentage uncertainty? Percentage uncertainty in mass, which is 1 divided by 4638, 463 into 100, plus the percentage uncertainty in volume, which is 23 divided by 188 into 100. So when you solve, you'll get 13% uncertainty total. So 13% is a total uncertainty. So it means this can be 13% more. This value can be 13% more than this, or it will be 13% less than this. So how to determine the 13% of 246? So it will be 13 into 2.46 into 1 divided by 100. So 2.46 multiplied by 3 divided by 100. So 0.07. So it means it can be 0.07 more or 0.07 less than this. So 13% of 2.46. So 13. Or you can also multiply like with 1.13, that is also 13% extra. So 2.46 multiplied by 13, and that is divided by 100. So 0.31. This is giving 13% extra means 0.31 more. So if it is 0.31 more, so 2.46 plus 0.31, so this will be 2.77. So the upper limit, upper value can be 2.77. Lower value, 13% less, so 0.31 less. So 2.46 minus 0.31. 2.46 minus 0.31, that is 2.33. So 2.33 less, so like 2.33. So upper value is 2.77, lower value is 2.33. So we'll check which one it matches with. Like the density of a soda glass is coming in this range. The density of borosilicate is 2.23, so that is not in the range. And the density of the perfects is also in the same range. So it shows that this is a soda glass according to our calculation. Or you can find the percentage difference between your calculated value, like you have 2.46, so your value and this, so calculate the percentage difference in each. If the percentage difference is more than the percentage uncertainty, it means the two materials are not same. But if percentage difference is less than the percentage uncertainty, it means two materials are same. So you can do both ways. The one which you find it convenient, you will use that technique. So this was Gen 2021 paper, Unit 3.